Today's LED tutorial is a custom rock diffusion project. I'll show you the steps for how I built this project, which will hopefully be an inspiration for a similar project of your own. Keep in mind that although this project is custom designed for my desk setup, there are many other possibilities for how you can remake this setup for your own space. For example, you may be able to buy or 3D print a container to hold the LEDs and rocks in order to achieve this same effect. To start, I'll briefly mention the main materials that I used. The key item for diffusion in this project is a mix of small and medium white pebbles that I bought online. They are decorative pebbles which even glow in the dark. The button and controller stand are 3D printed, and the electronics which power and control the effects are stored within the button assembly. The lights are WS2812B LEDs and are controlled by an ESP8266 module that is programmed with the WLED firmware. The idea for this project began with the button. I wanted a button on my desk which will allow me to easily turn on and off all of the WLED lights in my room at once. So I bought this 22mm diameter button online to do just that. I had also bought this multi-ring light a long time ago, which I hadn't used for a project yet. It consists of several WS2812B LEDs with breakaway tabs for separating the rings. I was inspired by its shape though and decided to use the whole thing in the design with the button placed in the middle. I spent some time experimenting with the lights and considering my options for how I could build the button casing and diffuse the LED pixels. I had considered constructing a wooden frame, but instead decided that 3D printing the case would be much easier due to the circular shape. So I jumped onto Fusion 360 and began creating the 3D model. I first created a model for the multi-ring light. I started with the center ring of LEDs and made larger copies around it. With the full model, I was able to plan out the circular diffusion grid around each of the pixels. After a few hours of modeling, error messages, and remodeling, I finally had a working diffusion grid model. I also found a 3D model of the button available, which was necessary for planning its placement. You'll notice in the model that in order to fit the button, I had to cut away at some of the grid in the center. I attempted to make the model with the ability to snap together for the base and top. But after spending a lot of time trying to figure it out, I decided to move on with printing it and superglue it later. I printed the base and grid using black filament, and then printed the top diffuser with white filament. Getting into the electronics now, I first had to remove the center pixel from the ring to make space for the button. Then I could begin soldering the wires. Each ring has 4 pads: data in, 5 volts power in, ground, and data out. The 5 volts and ground can be wired straight across. The data lines, however, would need to cross over so that the data out from the first ring would feed the data in of the next ring in the sequence. The button has 4 terminals: a positive, a negative, and the normally open and common terminals. The positive and negative terminals are meant for the built-in ring light of the button. I decided to leave this unconnected for now, since it would require additional circuit components. The button operates on 5 volts power, which means the microcontroller would need an external MOSFET and pull-down resistor on the gate to include that functionality. I soldered a 10K ohm pull-up resistor across the positive and common terminals. The input will be set to active low. Therefore, adding a pull-up resistor is important here to prevent false triggers on the input of the microcontroller. With the ring light ready, I began connecting it to the microcontroller. I had added a 100 microfarad capacitor here, which is going to help provide stability for the power supply when the LEDs are cycling through the different animations. I also used the leads of the capacitor to solder the other wires for power and ground of the input and output connectors. At this point, I had soldered the buttons on, but you'll see here that I made the mistake of forgetting that the button needs to be mounted through the 3D printed top before soldering the wires. So I unsoldered that connection and redid it. I added some hot glue in a few places on the wires to help provide strain relief and prevent too much pull from ripping the strands off a solder connection. It's always a good idea to check for shorts with a multimeter as you go along, and before powering anything on, to avoid risk of causing damage to your project. To finish the button assembly, I added a few spots of superglue to seal the top with the diffusion grid. I am leaving the base unglued for now in case I need to troubleshoot issues later. I did a quick layout check to confirm the components would fit where I'd like. The next step would be to cut the base plate which will hold the rocks. My plan here was to build a frame which connected with the monitor stand to hold the rocks in place. After getting the measurements planned out on a piece of paper, I grabbed some scrap metal to use for the base plate and transferred the outline of the shape. I then used sheet metal snips to cut the outline that I created. To make sure they came out symmetrical, I used the metal plate that I had cut as a template to create the outline for the other side. Now a few runs through the bench grinder wheels would clean up the sharp edges. To build the outer frame, I used 1/2-inch PVC piping. I decided to sand it down a bit to help the paint stick on better later. I'm using 1/2-inch caps and 45-degree elbows to connect the pipes together. I made some quick measurements in order to cut down the PVC pipes. Finally, I painted them black to match with my monitor stand color. Once they had dried, I attached them to the metal base plates using superglue. Next up, I began cutting the LEDs that go under the rocks to the appropriate length of strips. I was careful here to calculate how the route would go for the data in and data out connections between the strips all the way to the end. Then I went ahead and exposed the sticky backing of the strips to attach them to the plate. Once they were all attached, I began soldering the wires to connect the strips. I realized after soldering all of the 5-volt wires that it would be best to add some insulating material between the plate and the connection points, since the plate is conductive and might accidentally short the connections. So I put in some small pieces of electrical tape. Then I continued with the remaining solder connections. After completing the first section with the lights, I brought over the button controller and connected it to the strip for a power on test. Once I saw it was working, I poured the large and small rocks in to get a look at how it would turn out. Now, to begin working on the other side, I 3D printed the controller stand using black filament. To power this side, I used a 3-conductor ribbon wire and routed it under the monitor starting from the last LED on the previous strip. I repeated the same steps here to install the lights and wire it all together. And with that, it's done. There are many effects in WLED, and I have been experimenting with them to find the best modes for this setup. Here are some of the modes I have tried so far.